Okay, so it is 7:30 and we can start. So the computer wasn't working, so there's no camera for the recording today, but I don't think that is going to affect anything that too bad. And thank you for your adapter.
Keep it.
I don't need to keep it. I have one. I just didn't know I would need it. Yeah. Because I mean it's supposed to work. All right, so today we are going to start our review of chapters 1, 2, and 3 to prepare for the exam next week on Monday. And what we're going to do is I'm going to put up a question that you guys will be able to do and first work on it on your own. And when you are done, we're going to use the poll to indicate when we are done. So the code for today is 548. And we're just going to use the same question. For this first question, when you're done working on your own, just answer A.
Might be early for me. What's the question asking?
Oh, sorry. The first question is, what's the average CPI? And this is a multi-part question, so there's some information that you don't need yet. I don't see any new respondents. And I think most people that were here when we started are done working on this individually. So now we should go over the question with the people around us and talk through how you got to your answer and edit your answer if you need to edit your answer. And when you are done with the peer discussion, change your answer from A to B.
Execution. So you need the execution. Budget strategy, that's two. I think it's so that the latter just trying to. This is going to be a question. I was going to start with something people start out of the hours. You should totally sexual study, but there's multiple questions, so there's not everything is really. No, that's what you're seeing. And this is really here, so it's that's way to tell. I guess when you're done with the original thing, I know pieces of production. Have healthy peer review of the confirmation. I think the hardest book for that is right now. It's the close. See my brain. But then it is like,
Yeah, I don't hear discussion anymore, but only 56% of you have switched to B. And now everyone is switching. So let's go over this together. What's my equation that I'm going to use? Execution time. Let's just start with the original equation. So execution time is equal to instruction count times CPI. And then I have two options, right? It can be times cycle time or divide by clock rate, but we're given clock rate, so let's do divide by clock rate, right? And then I have all of the information I need, except I don't have CPI. So like you said, let's move this equation around. So we get execution time times clock rate divided by instruction count is CPI, right? So what's my execution time? 100. My clock rate is 2 to times what? And then instruction count is. So conveniently, this happens, right? And then 200 divided by 80 gives me. So my CPI for the program is 2.5. So the next part of this question is we have a new optimization that's going to reduce the CPI of branch instructions by a factor of 2. So the question is, what is the expected speed up of the program given that? So Again, work on this on your own. When you are done on your own, switch from B to C on the poll. So just as a reminder, do switch from B to C. Okay, some people are still working on this, but most people are done. So you are still working on it, just go through what you have with the people around you for the peer discussion, and you guys can finish through the rest of it together. And again, when you're done with peer discussion, switch from C to now D.
Maybe some branching. Yeah. The trick is to minus the PPI. The rest of the instruction is. So like, we know that that's very well, assume the rest of the instruction. You're checking maybe like 2.2 65%, 6.2, 35%.
I got this. And there is a specific thing. I don't know how to work that. You're always with phone. I guess like expected numbers. Do I have to do second size? You're right. Well, I would do what I did for ratios and areas that she might not be right.
Okay, so I hear discussion has died down. Let's just again switch from C to D if you are done. All right. So we need to find the expected speed up here. First thing is we already know what ET old is, right? Is ET old, not CPI old. Yeah, it's 100 seconds. So we just need to keep that in mind. And the first thing that we need to do in order to calculate our new execution time is figure out the portion of the CPI that was contributed by all of the other instructions. So we had 2.5 was our CPI old, right? And this is going to be equal to our branch 0.35 times its CPI of 4, right? And then we have everything else, which is 0. What? And times x. We don't know this yet, but we have one equation, one unknown. We can solve for this. So what's this 0.35 times 4? 1.4. And then I can just also turn this. I don't really need to include the 65 here. We can just write it out as x here. And then 2.5, 1.4 plus x. We have x, which is the contribution to CPI by everything else. What is this? 0.1. Okay. And then CPI new is 1.1 plus what? 0.35 times 2. And then what is this going to give me? Right? And now ET new, using my same equation that I had. So I have instruction count, which was 80 billion. And then I have CPI 1.8. And then I have clock rate, which was 10 gigahertz, which is 2 times 10 to the 9. So ET new is, don't have my calculators. 72. Flat? Okay. And then speed up. What do I divide by what? 100 divided by 72. What is this? 1.3 what? 9 times. So we speed up branch instructions by 2 times, but overall our program is sped up by 1.39 times. All right. So the next question is here. And now when you are done with this one, we can move from answering D to answering E. And again, do this on your own first. Okay, I think most people are done with this. And if you are still working on it, you can again continue working on it with the people around you to finish. And when you're done with this part of the peer discussion, switch from E to A. So we'll just loop around.
You don't understand that I don't consider like fighting product. It's just how many there's more required. But if it doesn't say shit, you're in frustration because it's a those decisions are in frustration. These other jobs, I guess, it's tools. So like I was basically it was not having outside sectors as it was the 20 things expected to cover to the side started to just saying Six hundred seconds. Combination of these two. Six five pound.
Okay, so I see most people have changed their answer to A,
I'm just slowing.
and we can go over this together. So we have total time is 1000 seconds. There's 5 parts. Each phase takes 1/5. So each phase takes how long? 200 seconds, right? So ET, A, B, all the way to E, 200 seconds, right? And then we have these two different speedups, right? Phase A and B are sped up by a factor of 2, and C, D, and E are sped up by a factor of 1.5. So let's just split it up into 2 to make it easy for us. So now ET new is A and B together take how long? And it's sped up by 2. And then C, D, and E take how long? And it's sped up by. So what is this? 200 plus. Which is 600. And the question was, what is speed up? So speed up. What goes on top? And this is right. So this one is going to be a little bit more work to do, but is again going back to Amdahl's law to do this question. So do this one again on your own first. Switch from A to B when you are done. And it is kind of this 2-part question. You have to answer it for 100 processors and then 1000 processors, and then decide, is it worth buying those 900 additional processors to do this or not? see most people are done working on this. And again, if you are still working on this, you can finish working through it with the people around you. And then when you are done with the peer discussion, switch from B to C.
So I got maximum 1.5. That's 540. Yeah. It's just a lot of work. They get the original stuff. Take out 60% of this T40. But that by the way, something like the money that we can translate the whole thing. Makes sense. So if you do the same thing, it's maybe it's not going to be 100%. Right, the 100, I'm sure it's gonna be a lot back actually. It's like, oh my God, it's just like, very good. Like, six. What's it? Something that actually would be. Yes, this feels like it's about that. House of course. Back to 6 She's correct, yeah. I think it's speed up. Yeah. Maybe end up getting speed up 1,000 here. That's like 500. Exactly. 1.5. We're looking at 640. 6.2. Yes. We don't spend the budget by the end of the board. We don't get by. We're gonna have to spend the budget for the last. That's right. That's too. That's if I'm pretty good stuff. That's 640. We say that. I'm good. And then like get it down because it's like yeah.
Yeah, I think most of us are done. Do change your answer over. All right. So there's many ways to do this. I'm going to do it the way that I would like to think about it. So I'm just going to split everything up into serial and parallel. So ET serial, we have A and B are 60% parallelizable, right? A and B together is 400. So 400. And then that means 40% of it is serial, right? And then we have C, D, and E. Together they are. And how much of it was parallelizable? 20%, right? So serial is. And this gives me. And then ET parallel. So if that's 640, do I even need to do the 0.6 and the 0.2? What is my parallel? Right. So then let's do 100 cores. Right. So we have 640 that we can do nothing about, right? And then we have 360 divided by 100. So what is this? 640 plus 3.6, which is 643.6. So if we did speed up, this is 1000 divided by 643.6, which is, and then we wanted to ask, is 1000 cores worth it? And this is going to be, again, so 640 plus 360 divided by 1000, 640.36. And then for speed up, we again have 1000 divided 640.36. So what is this? So we have a speed up of 1.55 times with 100 cores, 1.56 with 1000 cores. So our conclusion is going from one to the other, not worth it. Even if it was 1 cent per processor, is it worth buying it? No.
Need to fill out the budget.
That's a different kind of evaluation that you're doing. In terms of just the performance, it's not worth it, right? So what's the other thing that Amdahl's law will tell us? Just going from here. Common case is serial. Why do I need to buy any processor? That is going to make it more parallel. I should optimize for serial, so I should get maybe a better single thread processor. Okay, so there is one more question, but I'll just leave it for you guys to do on your own. Yes, question. Uh-huh. Because total time is 1000, and we calculated serial 640, so the rest is parallel. Oh, so you can do the same thing of 400 times 0.6 and 600 times 0.2, and you're going to be 60. Any other question? Okay, so again, this is a good question for you to do on your own later on, and the slides are posted on Canvas, so you don't need to write this down or anything right now. But I do want to talk about your exam just for the last 5 minutes. So it is Monday next week during lecture time. You'll have the full 50 minutes to do it. Bring a calculator. Bring a scientific calculator if you have one. If you only have a graphing calculator, you just have to show me the notes on it, that the notes are all clear. And you can also bring a sheet of notes. You can write anything you want on it, 8.5 by 11, so no poster boards or things like that. You can write as small as you want. You can type it up in 0.2 font if you want. I don't really care either way. If you're doing 0.2 font, I don't think you're going to be using your cheat sheet, but for the most part, I offer the cheat sheet because it is a good study tool for you to work on before you even come here. So oftentimes, even if you don't need it, making it will help improve your performance on the exam. What's the other thing? Study guide will be due before the exam. And there will be no like late turn-ins for that. Question?
So it'll be due Friday.
No.
So
The study guide will be due Monday at 7:30 a.m. Because if you do it on the weekend, it's fine. But as long as you did it before the exam, it will be helpful for the exam. Yeah.
It's a cheat sheet front and back.
Front and back. So again, you can put as much information that you want on there. But the one thing that I will ask you to not do is just don't print out your homework. It's not going to be that helpful. Yeah.
This is in addition to the MIPS reference sheet.
Yeah, the MIPS reference sheet you will get from me. And please, when I give you the MIPS reference sheet, do not write on it.
you release them?
Standard letter size paper, so 8.5 by 11. So you can go smaller, but it's no bigger. And if you just happen to have like a non-standard sheet of paper, as long as it's not the super long one, like it'll be fine. So you don't need to like measure your paper or anything.
Like 17.
Hmm?
No, like 17.
Okay, so again, this is a good review for you to do on your own. That's some points. But we can end class now because we don't have time to go over this one.